Okay, this problem says a system consists of a disk of mass 2 kg and radius 50 centimeters. So there's the disk upon which is mounted an annular cylinder of mass 1 kg and inner radius 20 centimeters and outer radius 30 centimeters. So there's the disk at the bottom, and on top is this ring or cylinder. Okay. The system rotates about an axis through the center of the disk and the annular cylinder at 10 revolutions per second. What is the moment of inertia of the system? What is the rotational kinetic energy? Okay. So we'll call this the disk and this the ring. Okay. So the total moment of inertia is the moment of inertia of the disk plus moment of inertia of the ring. For the disk, the moment of inertia is given by 1/2 mr squared for a uniform disk about an axis passing through the center of mass, okay, perpendicular to the disk. For the ring, the moment of inertia is the mass of the ring times r inner radius squared plus r outer radius squared. Okay. All right. So let's put in these numbers and calculate the moment of inertia. So mass is 2 kgs, 0.5 meters plus 1/2, 1 kg, 0.2 meters square plus okay. All right, so all this works out to 0.25 plus all right, so we have the moment of inertia, and now for part B we have to calculate what is the rotational kinetic energy. And again, omega is 10 revolutions per second, and that is 10 into 2 pi radians per second. Okay, it's 20 pi radians per second, and pi is 3.14, so 6.62.8 radians per second. Okay, and kinetic energy is 1/2 I omega squared, 1/2 okay. Okay, 621 joules. So the disk is half a meter. Half a meter. Here's a meter disk. Oh, well, it's not quite a meter. No. So there's half a meter disk. About 5-pound disk this big, rotating at 10 revolutions per second, has 621 joules. And 621 joules, here's what you can do. Your weight is 600 newtons, you can jump about a meter. So that's how MGH. Yep. Yep. Yep.
So why would you add the two radii?
Oh, that's the moment of inertia of a ring.
Well, I mean, when you do R, so 1/2 m R1 squared plus R2 squared.
Yeah.
Why would you add both of those in the ring?
That's the moment of inertia of the ring. This is the moment of inertia of the ring. So here's a. All right, so here's a. Yeah, I mean, that's just the formula. If you do an integral, that's how it works out.
Okay.
But, all right. Any other questions? Okay, let's, I want to finish these problems and then we'll start the lecture on the next chapter. Okay.